What is up, everyone? In this video, I'm going to solve a real Golang interview question, a real Golang interview assessment, whatever you want to call it, because one of my members of the community, they came across this exact interview question assessment, and unfortunately, they tried to solve it, which I think he solved it in a good way, especially for a junior dev. Of course, some hiccups here and there, but they declined his apply. I'm going to try to solve it in my way. I'm going to show you how I would solve this, and I'm going to give you some tips and tricks along the way if you're facing an assessment or an interview for a position as a Golang developer. If you like the content I'm providing to you, still 50% of my viewers are not subscribed yet. Consider subscribing to the channel, give me a thumbs up, leave a question in the comment, jump into the Discord. Let's fucking go. All right, so the assessment. This is exactly the text they gave him. So I will read it real quick. So they say, create a library for caching user information to increase database throughput and availability, right? Every request for a user data should return user information while simultaneously taking care of database throughput. It means the library should take care of unnecessary requests for user data if some are pending. All right, the first thing I really don't understand if it means the library. I don't know, the library. Very obscure, but anyway, say why. Let's say we have a bunch of user information identified by ID inside our main database. Simultaneously, there's thousands of requests per second for user information. We can consider a database is a bottleneck. To avoid that, we need a caching mechanism. Notes, you can use any language, library, database, and framework, anything you want and think is best for this case. Example, if within 1,000 requests, there are 100 unique user IDs, then there should be only a maximum of 100 requests to the database, but all 1,000 requests should get a response with user data, which is basically caching. That's what caching do. That's basically, this whole assessment is implement a cache. It is what it is. So that's what we're gonna do. We're gonna this example, right? We're gonna solve this example. That's what we're gonna do. That's what they provided us, and we're not gonna do extra work, and we're not gonna do less work. We're just gonna solve this issue as soon as possible. That's what we're gonna do, because it's also our time, and a lot of people try to overcomplicate the solutions for these assessments, spending days, maybe a week or something. It's your time. Time is money. They need to understand that you are the developer. They need you, and especially if you're a high-value engineer, there are less high-value engineers than companies looking for them. So it should be the other way around. Anyway, so let's solve it, right? So we go to main. The first thing I'm going to do is I'm going to make a server, which is going to be, let me position my keyboard. Yes, that should be fine. We're going to make a server, which is going to be a struct, right? The server is going to have a DB, which is going to be a map of integers mapped to a user, right? We don't have a user. Let's make one. Type user. It's going to be a structure. We're going to say this guy is going to have an ID, which is an int, and also a username for the sake of, right? That's fine. Then we're going to say func new server. That's going to return a pointer to a server like this. We're going to say that the DB is going to be make me a map of integers mapped to pointers to user, right? Then we're going to loop. We need 100 users, right? 100 unique users. So we're going to say 100. We're going to say that the ID is going to... wait, what's going to do? We're going to say DB y plus 1 is going to be a pointer to a user. We're going to say that the ID of the user is going to be y plus 1. So we don't have this null value, right? And the username, we're going to do something very simple. We're going to say empty as printf user underscore percentage d y plus 1 and call it a day. Right, so we're going to populate the database, right? And I'm going to return our server. And we're going to say that we have a DB, which is going to be a DB full of users. Cool. All right, the next thing I'm going to do, instead of making this in main, I'm going to use we're going to make a test for it. So they can run the test. We're going to do the requests, and then we're going to print out all the shebang to prove that we solved the solution. And yeah, that's what we're going to do. So I'm going to open up server test. We're going to say func test handle get user. Yeah, should be fine. We're going to say a t. It's going to be a pointer to testing.t. Then we're going to say s is going to be a new server, like that. We're going to say that the ts, which is going to be a test server, is going to be an HTTP test new server, I think. And then we need the handler. So we're going to say HTTP handler func. Wrap it in our server. Did we already got this? We don't. We don't. Let's comment this out. This one, we forgot something, I think. Of course, we forgot something. So we have this new server. What we're also going to do is create a handler, of course, otherwise we can't test it. We're going to say func s server handle get user, just like that. W HTTP. Let's make a handler, right? Classic Go handler, response writer, a request is going to be a pointer to an HTTP request. Like that, we're going to fetch the ID. It's going to be a string first, right? Because we're going to get it from the URL, which is going to be sr URL query, I guess, get ID. Yes, perfectly fine. Then we're going to convert this to an int. ID. We're going to skip the error. You could say, why are you skipping the error? I don't think it's necessary to do this, right? In production, you would actually handle the error, but hey, like I said, time is money. And you can tell them that. They like that because time is money. So you should actually handle the error, right? So ID is going to be a string conf, str conf atoy, I think, a to y, ID str, like that. Then we have an ID, it's perfectly fine. Then we're going to say that the user or OK is going to be sdb ID. If not OK, we're going to just panic out, right? Normally you should make a nice response. User not found. Man, this font size is huge, especially for you guys. The screen is huge. So then we have a user. Then we're going to basically return that user as a response. So we're going to say JSON encoder, new encoder is going to be W, encode me the user. Call it a day, right? This is our handle get user. Okay, let's open up our test. So we have this HTTP test server, and then we're going to say it's going to be s handle get user, just like that. And then we're going to spin up how many requests that we need to do. Nrec is going to be 1000, right? That's what they told us in the example, 1000 requests. So we're going to say looping for the nrecs, right? We're going to say that the URL is going to be fmt s print f. Could make a mistake here, not sure. We're going to then we're going to say something like ID question mark ID equals %d. Why is that going to work? I don't think so, because we need to have 100 users, right? We need to fetch. We're going to do 1000 requests, but we're going to cycle between 100 users. So what we could do is something like the ID is going to be y modulo 100 plus 1. So we don't have 0. So we're going to say it's the TS URL, right? This is the URL of our test server. And then we're going to, I'm so sorry. We're going to say ID. Then we're going to say that the response error is going to be, and we're going to do a simple GET request, HTTP GET. Get rather not to the URL we just created, right? If there is an error, of course, we're going to t error this R. Then we have a response. So we're going to say that the user, which is going to be n user, pointer to a user. We're going to say if R equals JSON new decoder response body caps decodes the user, and if the error is not null, What's going on here? We're gonna the error F, no error, the R. Man, what a shenanigans here. So that's fine. And then we have the user. And then we're gonna actually basically print out maybe println the user we just fetched. Actually, you could do a printf with a percentage plus v, new line, user. Nice. Okay. Yes. I think that's fine. Let us go test this real quick. Boom. Right. So we're doing all these requests. We are cycling between. We're doing 10,000 requests. We are cycling between all our users. And what we could do is basically open up our main real quick, and then we're gonna go to our server, right? We're gonna say db hit int, right? db hit, and then we're gonna say here if we have a user from our db, hit the db database like here. Then we're gonna say dbs db hit plus plus, right? Boom. That's fine. Then we're gonna go to our server test once again, and then we're gonna print out println, delete everything inside. And we're gonna say we hit the db percentage. We can't. Wait, I have a better idea. Times we hit the database. It's gonna be sdb hit. So times we hit the db. Wait, what are we doing? 1000, that's fine. Let's print it out here, right? And then we have a clean, and we don't print it out all the time. So we're gonna do go another test. Boom. Right. Times we hit the db, 1000. That's a problem because that's not what they want. They want for these unique users, the 100 unique users, they want only 100 requests to the db, and all the rest needs to come from the cache, right? So that's fine. Let's implement that. This is the problem, and now we're going to implement the solution, right? So how are we going to implement this? It's, in my opinion, a very simple problem to solve. We're going to say we're going to make a cache, right? And it's going to be the same thing. I'm going to delete this, paste it in here, so we have a cache. Then we're going to say that the cache here is going to be make me a map int pointer user, right? Just like that. What's going on? Cache, I cannot type or spell or both. Okay, so let's make a real a simple helper function. You're going to say server try cache, which is going to be an int, an ID int, right? And it's going to return us a pointer to a user or a bool. You could say return an error, that's true, but if they say something from that, you could say yo, but if the cache does not have our user, we don't need to spit an error because we are going to fetch it anyway from the database. So just a bool to check. Of course, your cache could be broken and could return an error, like maybe it's not available or something. As a design decision you need to make. In my case, I just use this bool because if you have internal loggings in your Grafana Elasticsearch, you will see if there's something's wrong with your Redis cache or something else. You will see that there and you can fix that. So in my opinion, no need to return an error. A bool is good to check it. So what we're going to do is we're going to say user OK is going to be s cache. It's going to be ID, right? And then we can just return, what's going on here, return the user OK, right? A small helper function. So the first thing we need to do, first, we're going to say first try to hit the cache, like this. So we're going to say user OK is going to be s try cache with the ID, right? And then we're going to say if OK, if we find it from the cache, then we're going to actually, let's yoink this thingy here, boom, and then return so we don't hit our DB, right? That would be nasty. So hit the cache, then we hit the database, which is basically already assigned, that's fine. And then once we hit the database, we need to warm up the cache, right? Warm up the cache. That's actually not a warm up, basically insert in cache. In cache. Because a warm up is basically what, if you reboot your application completely and the cache is empty, what this company is doing, what the industry is doing, they basically make some random request to warm up the cache themselves. All right. So insert in the cache, very simple. What you're going to do is as cache ID is going to be user, right? Easy. Cool. Let's test this. Boom. Yes, so we do all these requests, and you can see times we hit the database 100. So we already solved the issue. So instead of 1,000 requests to the database, we only have 100 requests. That's exactly what they want. Okay, but you could say, yeah, Anthony, fine, but this cache and all that stuff is not concurrent safe. You're 100% right. But for the sake of, it does not need to be, right, in the sake of this thing. If they say something from it, you could say, hey, no worries, let me live code this a quick mutex and solve the problem, right? I mean, not big of a deal. So what you could do in server is basically, because they will say, yeah, but that's not concurrent, right? So you could say something like, yo, no problem. You're going to say go func y int, because we need to encapsulate this y. Are we going to get problems? It's going to be y just like that. Yes, fine. So we're going to basically spin up a Go routine, 1,000 requests, all Go routines, let them go async. What we're going to do is basically, we're going to do a little sleep here. It's very important, because otherwise we're going to get issues with our HTTP test server. So we're going to say sleep, and very, very small microsecond, because this is going at the speed of your PC, right? It's going at the speed of your PC. There is no such thing in real life that goes as that can make HTTP round trips at the speed of your PC. It's impossible. So we're going to say time milliseconds. Actually, 1 is fine. You could even use a microsecond if you want. Of course, we need to synchronize this a little bit. So we're going to say a VG is going to be a sync wait group, just like that. Each time we make a request, we're going to say VG add 1. Right, and each time this guy is done, we're going to say VG done. And then we're going to wait here, VG wait until everybody is done, right? And then we're going to print out this shenanigans. Let me see if this works. Maybe not. Who knows? All right, so it's working, and we have, yeah, it's all concurrent. And we basically hit the database 100 times. You could make this even more complex by adding you could mock some HTTP round trips with some random durations, but hey, like I said, I'm a business owner myself. I'm a CTO of my own company, and I hired a lot of people, and I don't like to see complexity, right? Complexity is bad. A lot of coders, they come in companies and on forums, they want to look smart, they want to be smart, so they make things so complex. Yeah, but you could use this and this wine-liner and a mutex here, and they make so many things complex, but we don't want that. We as business, as CTOs, we don't want complexity in our teams, because it will basically just make everything unreadable for the other guys, right? What do we want? We want people that can solve, that can hack a solution together, right? As fast as possible. So we can test an issue, we can test a feature, and then we can make it better, right? But we need somebody that can think and quickly implement something that's kind of okay, that works, that solves the problem, and then we can make it better and iterate upon. That's exactly what I'm doing here. Is this the best solution? Is this a solution for production? No. But it solves the problem, right? It solves the problem. That's what it is. All right. So basically, that's the thing. Go test. Yeah, perfectly fine, right? So we iterate over these users, 100 only, and the rest is going to the cache. So let me quickly find, I think I have it already open here. Where is this thing? Tasker. I cannot find it. Let me quickly look this up. In our Golang, in our Discord. Where did he post this? I'm going to find it instantly. This is Golang migrate. That's not what we need. We need this Redis cache. Tasker, channel comments. What is this? This bullshit Patreon stuff. Boom, boom, boom. Okay, so this is basically the solution from Grobson, right? And I think, in my opinion, his structure is fine. His folder structure is fine. No complexity here. Nicely organized types, Redis main, and all that stuff. Let me see what database is real quick. Yes, you make a new Postgres database and all that stuff. Fine. Clean code, right? If you took API, clean code. Just a little problem here. And that's basically here, this Redis, right? So for each request, he's basically spinning up calling new Redis, right? And new Redis basically creates a new client and all that stuff, and that's not good. So you need to, at startup, you need to create your client and then put it in some struct or something, or in a context so you have access to it, so you don't need to re-initiate, create the client all the time, right? So that's the thing. But besides that, I think it's, for a junior dev, a very good implementation. But there are some problems, right? There are some problems I want to discuss. So code-wise, I think okay, right? He understands Go. He knows where to find things. He makes things idiomatic. Fine. Besides this little Redis thing, maybe he basically looked over it or he forgot. Hey, shit happens, right? But the problem is, if you want to make an assessment, right, and you make these things, so the problem is how are they going to test this, right? The only thing he has basically is... the only thing he made is this main function, right? And the only thing it does is basically it starts in your Postgres database and there is a server ready and you can run the server. But how am I going to do requests to this? None in the README. And if I want to test these 1,000 requests, then I need to spin up my own tester, or I need to do 1,000 requests manually. Where can I see that it's solved? Right? So you need to understand that this guy needs to have Postgres installed. He needs to have Redis installed. He needs to have this database completely set up with his, maybe, I don't know, maybe his database has another user or something. What kind of user? Or is it Postgres? Is it your local name on your system? I don't know. So that could be a big problem, right? So these guys are not going to test it, right? And then you need to understand that if some guy like me or somebody else that just hacks together our solution here, right? Where you could just say, yo, just do go test, right? So he just forks this or he clones this and he does go test, boom. And it sees everything happening on the screen. And then we say times with the DB. That's amazing, right? That's amazing. The only thing he needs to do is check the code and he can basically instantly see that we have a cache and all that stuff, right? So the competition is hard, and that's probably the reason why he did not make it through the next round, because he made things a little bit too complex by using Postgres, by using Redis, and not providing to the point, right? Not providing the solution to the problem without all these dependencies, right? So basically, that's a very good tip for you. First of all, it's also your time, so don't make things too complex. Don't spend too much time, right? Just identify the problem, fix the problem, and make sure they just need to run something, and they can see that the problem is solved, right? That's your goal. Unless they ask specifically that you need to install Postgres and that you need to install Redis and that you need to use these two and all that stuff, and that maybe they ask that you need to use a real database, right? They didn't ask that. We could do whatever we want. We just needed to solve that example here, which basically is exactly what we solved, right? And the second thing is that don't make things over complex. Don't try to do more than you need to do, because it's something that I experienced in my career, where I needed to do a simple assessment and I made this so crazy. I spent 2 days on it and it's probably the best they ever seen, but it was too complex. Right? It was just too cool. It was solving more things that it needs to solve, which we don't want that like I said, like a CTO, we don't want people that makes things too complex, right? Keep it simple, keep it short, go to the point, and that's the best thing you can do, right? If you like this content, subscribe to my channel, leave a comment, give me a thumbs up, join the Discord. And for the people that really want to level up, really want to learn very, very, very core stuff, very distributed stuff, systems programming, that's basically nowhere to be found on YouTube, and I swear to God, never on the internet. Check my Patreon page, where I'm building the most insane stuff that will turn you into a high-value software engineer. Thanks for watching, and I'm looking forward to see you in one of my live streams or future videos. Bye-bye.